Hey friends, we're back. One more question that I would like to do with you. Okay, in this case, we have a different setup. Remember, I told you that we'll pretty much always find a slope and a point, put it in point slope form, then convert it into slope intercept form, like this stuff up in here. That's like exactly what we're going to do up in this one. But the situation is we currently don't have any points written down and we don't have any slopes written down. We're not giving, but we have the graph. So we're going to look at the graph and we're going to find this information from the graph. So right here, if we look at it, we have 1, 2. We have the x coordinate of 2 and a y coordinate of 1, 2, 3. A y coordinate of 3. So we have a point that's shown 2, 3. Now we want to find the slope. So how do we find the slope? Well, we don't start from the origin to count the slope. We have to look at the graph and we have to find another point that's on the line. So that point works, this point works, and we can calculate it using, slope formula if we wanted, or we could just count it from the graph. So up 1, 2, 3, right 1, that is 3 over 1, rise 3 over to the right 1. So we have a slope of 3 that we could use. Notice how it's a positive slope. The line is going up from left to right. So now we can go ahead and use either of those points to drop it in point slope form. I would highly suggest using this first point that shows up because it's a nice, beautiful spot. So x1, y1. So y minus, x minus, drop some things in, y with y, x with x, and then let's drop our slope in there, our slope of 3. That becomes our point slope form. After we do that, we can distribute and go from there to find our slope intercept form. Y minus 3 equals 3x minus 6. Why did I write a parenthesis for fun? Now we turn around, add 3, y equals 3x minus 3 becomes our slope intercept form. But and that leaves our y-intercept 3. But guess what? Look at the picture. Could have cut to the chase after we wrote point slope form, not done any calculations because on the graph of -3 on the y-intercept is already shown. You know what I mean? You know what I mean? That's what I mean. All right, let's do one more because that was a relatively quick one. Okay, so we have this point. So this is we're going to find the slope, we're going to find the y-intercept, we're going to find point slope form, and we're going to find slope intercept form. That's what we're doing. So again, we're going to find a point, we're going to find the slope in some way, put it in point slope form, rock it out from there. So here we go. This point being 4 to the left, that's our x, -3 being our y. So now we're going to use that and, oh wait, we got to find our slope. So let's drop this point right here. That looks like it's crossing perfect. So -1, 1, 2, +2. So -1 over 2 is our slope based off of reading it from the graph. You could turn around, find this point, -2, -4, and then use the slope formula if you felt like it, but why would you do that? So anyway, so let's turn around and drop this into point slope form. So y minus equals x minus. We're going to drop it in using the point that was given. Make it easier. So y with y, so -3, x with x, -4, and drop your slope in the spot where it goes. Notice how we have plus, minus, minus, so that's going to change to +3, minus, minus, again, +4. That becomes our point slope form. Now, if you remember what I said at the end of the last problem, that y-intercept is perfectly drawn. So it's going to be 0, -5, which y-intercept being -5, we could just drop it in without doing any calculation, and we know our final answer is y equals our slope x minus 5 being our b. Or you could have turned around and gone through this process, distribute that, -3, and notice how we get to the same exact spot. That's super exciting. Anyways, go ahead and finish the notes, and yeah. Let's get it. See you tomorrow. Peace.